Okay guys, so we are going to take some notes today to finish up 5.6, which deals with complex numbers. We started that yesterday, and depending on what we got through yesterday, the first part of the notes may be a review or it may be new. But it's going to deal with multiplying complex numbers. So we know complex numbers have a real part and an imaginary part. And when we multiply them, really all that we have to do is just FOIL them together. So this first example, 2 plus 3i and 4 plus 6i. You know, the I isn't technically a variable, but it acts a lot like the variable in how we approach this problem. So we're going to take 2 times 4, which is 8. 2 times 6i, which is 12i. We actually get another 12i in the middle. 3i times 4 is another 12i. And then 3i times 6i is 18i squared. So, first thing I want you to realize is that these two 12i's are going to add together. They're like terms. That's 24i. One fun fact that you want to remember or know is that if I is equal to the square root of -1, then I squared is just the number -1. And that's important in this problem because we have an I squared. I'm going to replace that I squared with the -1 that it's equal to. And that actually now makes this a -18, which I can combine with this 8 to make a -10. So that's our answer. So this became a -18, combine it with the 8, and we've got that -10. So let's try this again. We're going to take 3 and multiply it by 9, and we have 27. 3 times 12i is 36i. -I times 9 is -9i. And then -I times 12i is -12i squared. I'm going to make a little box around this stuff up here. So, we know that 36i minus 9i, that will combine to 27i. This I squared becomes a -1. That's what it's equal to. And this minus 12 times -1, that's going to become a plus 12. So, that plus 12 combines with that 27 to make a 39 plus 27i. So the key thing here, you have to remember that I squared is equal to -1. Okay. So multiplying is pretty easy as long as you remember to 1, FOIL, and 2, that I squared is equal to -1. Dividing complex numbers probably sounds really scary, but it's not actually too bad. The key thing to remember with complex numbers is that I is not allowed in the denominator. So if you think about why that is for a moment, I is equal to the square root of -1, and we know that square roots, they're not allowed in the denominator. It's sort of like bad math grammar. So keeping that in mind, if you notice this first example here, there's an I in the numerator. That's okay. An I in the numerator is perfectly fine. But there's also an I in the denominator, and we have to adjust that or fix that. And to do that, we multiply the top and bottom, both the top and bottom, of that fraction by what's called the complex conjugate. Now, what is a complex conjugate? Well, it's super easy. If we have the complex number 3 plus 7i, its complex conjugate would be 3 minus 7i. Notice, you just changed the sign of the imaginary part. That's all complex conjugates are. So in this first example, one thing that students try to do, which would be completely incorrect, is they'll want to cross out those i's. You can't do that because of the plus and minus signs. So what we're going to do is we're going to take this fraction of 2 plus 3i over 4 minus 5i, and we are going to multiply the top and bottom by the denominator's complex conjugate. Notice, we're never really concerned about the numerator. Alright, 2 plus 3i is fine. It's the 4 minus 5i in the numerator that is a problem. We look at that denominator. We look at that denominator. Its complex conjugate will be 4 plus 5i, and we're going to multiply the top and bottom by that. Which looks scary, but all that we have to do is FOIL the top together and FOIL the bottom together. So, 2 times 4 is 8. 2 times 5i is 10i. 3i times 4 is 12i. 3i times 5i is 15i squared. And we're going to do that on the bottom as well. 4 times 4 is 16. 4 times 5i is 20i. Negative 5i times 4 is a negative 20i. And negative 5i times 5i is negative 25i squared. So you might be thinking, wait a minute, this just got worse. There's now way more i's. Well, it initially looks that way, but if you have done this correctly, all of the i's in the denominator will disappear. These will go away. 20i minus 20i cancels. And we know that this I squared is negative 1. So negative 25 times negative 1 is a positive 25. So that's good. I'm just going to write that. So that's what we have on the denominator, and I'll combine those in the next step. On the top, 10i plus 12i, that's 22i. And then 15i squared, remember that I squared is equal to negative 1, so 8 minus 15, this becomes a minus 15, is a negative 7. So we're just going to add the 16 and the 25 together, and that gets us 41. And there you got it. So let's do one more here. So, notice this division problem. There's an I in the bottom. That is not okay. We cannot keep it there. The I on the top is fine. To fix that, what we do is we take the complex conjugate of the denominator, not the numerator, the denominator. The complex conjugate of the denominator will be negative 7 plus 2i, and we multiply that on the top and the bottom. Alright, so both. Now that requires a lot of FOILing. You can put that in parentheses if you want. Negative 1 times negative 7 is 7. Negative 1 times 2i is 2i. I'm sorry, minus 2i, minus. 3i times negative 7 is negative 21i. 3i times 2i is 6i squared. Negative 7 times negative 7 is 49. Negative 7 times 2i is negative 14i. Then we get a positive 14i. Then we have a negative 4i squared. Okay, lots of I squareds in there. So again, we have to remember that I squared is equal to negative 1. On the bottom, we get these 14 i's to cancel, and we are going to have a 49 plus 4 because this I squared is a negative 1, and negative 4 times negative 1 is positive 4. On the top, negative 2i minus 21i is negative 23i. This becomes a minus 6, so I have a 1, 7, minus 6 is 1. 1 minus 23 on the top, and then adding the 49 and the 4, we get a 53 on the bottom. And there you have it, folks. Okay, guys, so that should be, enough to get you through the homework for tonight, so make sure you do that, and I will check that tomorrow.